Hi, welcome back to McClatchy Maths. My name is Natalie McClatchy and today we are continuing our series on Pythagoras' theorem and trigonometry by looking at some applications, and one of these is Heron's Rule. Heron's Rule is a way to find the area of a non-right angled triangle. I'm going to introduce the rule to you shortly, and then we'll look at some worked examples and talk about what's coming up. Now, one of the things you'll notice about Heron's Rule is it doesn't appear to have trigonometry in it as such. However, it is derived from trigonometry, and there is a very complicated derivation. There's a couple of ways it can be derived. It is quite complicated. I won't be going through how the rule was developed in this video. We'll stick straight to introducing that rule. So let's consider a non-right angled triangle ABC, and I've labelled all of the sides with a little a and a b and a c, and also the angles A, B and C. Now, we've previously found that area when we know two sides and one angle in between them. For example, if we knew C and B, the little sides C and B, and we knew angle A, we could use our previous area formula that we looked at in the previous video. However, what if we don't know anything about any of the angles and we've only got information about the side lengths? In that situation, we actually need a way to work the area out. So Heron's Rule is applied when we have three sides given but no angles. And the rule looks like this. It looks quite complicated. Like I said before, there's nothing that looks like trigonometry in there, sines, cosines, tangents, etc. But it is actually derived from those principles of Pythagoras' theorem and trigonometry. Okay, so let's have a look at what this formula is. We've got this new variable, the letter s. S is actually this formula down here. What we do is we add each side up, so the sum of the sides, and then we divide that by 2. You'll notice this is not an average. If it was an average, we'd be dividing it by 3. So we're not finding the average of the sides, we're finding this value s. So it's a plus b plus c over 2. Now, s appears in the formula for Heron's Rule 4 times. So what we need to do is we need to work out these brackets. So s is going to be greater than each side because it's not an average. If we'd found an average, it would potentially be less than some sides and greater than others. However, because it's not an average, it's only divided by 2, it's going to be bigger than all of the three sides. So that way we are actually subtracting that difference from s in each set of brackets and then multiplying them all by one another, and then we take the square root to find the area. So it's not a difficult formula to use, but it is a tedious formula to use because there's lots of parts to it. So I would always recommend to students not to use Heron's Rule if there's a situation where you've got some angles. If you've got some angles that are provided, you could use the sine rule, for example, to find missing sides, and then you could apply then your area rule, half AB sine C, that we looked at in our previous video. So only use Heron's Rule if you've definitely got no information about any angles. Otherwise, you're setting yourself up for lots of complicated and tedious steps. Okay, let's look at our first worked example. We've got a triangle that's shown. We need to find the area below of that to 2 decimal places. And firstly, we need to recognize it has no right angle. Now, it is tempting for some students to drop a perpendicular line down the center here of the triangle. I see students do this every exam, and then they pop that right angle in there. Yes, it would be a right angled line that they're dropping down, but they make the assumption then that this perpendicular drop here is going to split the bottom line into 2 perfect halves, and it won't. As you can see, this side here is 6 centimeters, this side is 7 centimeters. It's not going to be an isosceles triangle when you drop that perpendicular down. So that's a common error that students make. So we simply need to recognize it's got no right angle, which means we need a different strategy. So firstly, we need to select the right formula. Once again, we know we've got no angles, so we can't use that area formula we've already talked about. So we've got to select Heron's Rule in this situation. So knowing which formula to select in which situation is a really important skill. You've always got to ask yourself, what sides do I have? What angles do I have? Is the angle between sides? Are there no angles? Are there no sides, etc.? And that way you'll be able to work out which formula to select. Now that we've selected the right formula, we need to find the value of s first before we can actually apply Heron's Rule. So we're going to add those three sides together and divide it by 2. And that will give us the number 12. So our value for s is 12. Now, s has no units of measurement. So don't write centimeters here, that would not be correct. No units of measurement at all. It's just a number or a variable that we're going to insert into Heron's formula. So we're going to do that now. There's Heron's formula. We need to write the formula down and then we substitute in. Notice that 12 has replaced all of the S's in the formula, and then it doesn't matter which side you choose as A, B or C, because there's no real need to worry about the order. 3 times 2 is the same as 2 times 3, so the order of multiplying things is not important. So we're simply subtracting those numbers from 12. Show you're working. Don't just jump straight to the answer here on your calculator. Show what's inside those brackets and then do one more step where you're going to find the multiplication of those 4 numbers together and then take the square root, round it appropriately to 2 centimeters, to 2 decimal places, and also make sure you give the correct units of measurement too, centimeters squared, because we've found area. Let's look at our second worked example. This is a little bit more complex now, and it's our last worked example for this video, so do hang in there with me. You may even want to pause here and see if you can do this one on your own. So in this case, we've got a quadrilateral. Now you might be thinking, well, aren't we doing triangles? Well, every quadrilateral is made up of 2 triangles on the inside. So we need to find the area of the whole shape. It's a composite shape made up of 2 triangles. So we're going to actually break it up now into 2 triangles by annotating. Now, we've been given a right angle in that bottom corner. That's going to make it really nice for us to find one of the areas. So it's tempting to actually draw your line down the center here. That's not going to help you much at all by making a kite out of it that way, by putting that center perpendicular. Use your right angle that you've got to make a right angle triangle here. Now we're going to actually label those 2 areas as well so that we can communicate what's going on when we're actually providing all our working. Makes it a lot easier for your teacher to see where you're going. So we're going to find the area of triangle 1 first. Now it's a right angle triangle, so we can just use our formula. That's a really easy formula, half times the base times the height. Substitute that in and we get an area of 150 meters squared for our first triangle, triangle 1. So that was the easy one. Now we need to use Pythagoras' theorem to find the third side of triangle 1, because you'll notice for triangle 2, we've actually only got 2 lengths there, so we need that third length. So we're going to use Pythag to do that one. So write your formula down, substitute your information in, work that through, showing all your steps of working, every step. This step here is the one that my school often gives the mark to, but your school may give a mark here. So show them all, and that way you won't lose any marks. And we've found that that side of the hypotenuse of triangle 1 is 25 meters long. So we're going to write that on our diagram and annotate that. Now we need to find the area of triangle 2. So to do that, we're going to use Heron's Rule because we've got no angles. So we've got only 3 sides. We're going to find S first. So we're going to put all of that information into the formula for S, and we'll come up with a value of S being 45, which we're now going to substitute into Heron's formula. So we put 45 in there, all the information about the other sides, and then we work that through nice and slowly, showing all our steps of working. And then we're going to have this final answer that has lots and lots of decimal places. We need to read the question carefully. It says to round it to 2. So we're going to round that at the very end, because if you'll note, we've actually got to do something with that. So we're going to leave that number with all of the digits on our calculator. And then we're going to find the composite area by adding area 1 and area 2 together. So you'll notice here that I use this ... to indicate that I'm keeping that number on my calculator. I'm not zeroing it out and then retyping it, because that means I'm rounding mid-question, and that means it's less accurate. So now we're going to add those 2 numbers together, and we can round at the very, very end to 2 decimal places. And notice I've also got the units of measurement there, meters squared, because we're finding an area. Well, that's all we've got time for on the video. I hope you found these 2 worked examples really helpful. We're going to look at some complex problems in our upcoming videos that combine all of these concepts of different area rules, sine rule, cosine rule, maybe a bit of bearings perhaps. We'll combine some of those concepts together, come up with a couple of complex problems to help you prepare for your exam if you're in general maths or year 10 maths. Then we're going to look at unit circle and trig functions. This is really for our students doing advanced mathematics in grade 11 and 12. So stay tuned, there's a lot coming for you. And if you found this video helpful, why not tell somebody? Tell someone like a teacher or a friend, get them to follow the channel as well. Tell us in the comments what you found helpful. Like and subscribe to the channel and follow us on social media. We're on Facebook and Instagram. We'd love to see you there as well. That way you can take part in competitions, memes, fun things as well. If you've got any questions about anything you saw in the video today, you can contact us at mcclutchymaths@yahoo.com, or could direct message us on Facebook or Instagram. And you've been watching McClutchy Maths. I'm Natalie McClutchy. Thank you so much for your time. Have a wonderful day.